Hello and welcome to the first class of the Apache Cassandra course offered by Jigsaw Academy. This class will provide you an introduction to Apache Cassandra. Let us understand the course prerequisites on the next screen. Before taking this course, it is expected that the learner has a working or functional knowledge of computer programming. The learner should also have a good knowledge of databases and SQL. Some knowledge of Linux or any Unix-based systems is also required. Now, let's get started to get an overview of the course structure. The Apache Cassandra course structure is shown on the screen. This course will have 6 classes. Class 1 will cover Introduction to Cassandra. In Class 2, we will cover Architecture of Cassandra. Class 3 will take us to installation and configuration of Apache Cassandra. Class 4 will explain Cassandra data model. Class 5 and 6 will cover Cassandra interfaces and advanced architecture concepts of Cassandra respectively. We will have a summary at the end of each lesson. The next screen will give an overview about the course objectives. By the end of this course, you will be able to describe the use cases and features of Cassandra, understand the architecture of Cassandra, and define Cassandra data model. You will also be able to explain interfaces to Cassandra and advanced Cassandra concepts. In this lesson, we will cover the history of Cassandra, main features of Cassandra, different Cassandra use cases and examples, Cassandra command line interface, and Cassandra advantages and limitations. Let's look at the Cassandra history in detail in the next screen. Cassandra was initially developed at Facebook by Avinash Lakshman and Prashant Malik. It was created to help in their inbox searching. Facebook developers named their database after the Trojan mythological prophet Cassandra. Cassandra was started in 2008 as a combination of Google Bigtable and Amazon Dynamo. Version 1.0 of Cassandra was released in 2011. It was handed over to Apache and became an Apache project in 2014. In 2014, version 2.0 was released and version 3.0 in 2015. In the next screen, we will look at Cassandra features. Cassandra has a ring-type architecture. Cassandra provides an automatic data distribution across all nodes that participate in a ring or database cluster. Here, the nodes are organized such that every node is connected to every other node. All the nodes are equal. One can connect to any node and get the required data. One can also update data using any node in the cluster. Cassandra has a linearly scalable architecture. Cassandra is highly scalable and one can achieve linear scaling while storing petabytes of data. In normal distributed systems, the scalability tapers off as you increase the number of machines, whereas with Cassandra you will get linear performance increase as you add more machines to the cluster. This is suitable for big data systems where you need to add more machines as the data grows. Cassandra has a tunable consistency. Relational databases have performance bottlenecks as inserts are atomic and selects have to wait for the insert to complete. Cassandra makes it possible to read the data even when writes are happening to data by compromising on the consistency of data. Based on your application, you can choose a consistency level. Cassandra supports data replication across data centers. When data is first written, it is also referred to as a replica. With global operations, enterprises have data centers across the world. To access data in one data center from another is time-consuming due to the latency of data transfers. To keep copies of data in both the data centers is difficult so as to keep the data in sync. Data is made available at all the data centers. Cassandra automatically handles syncing of data. Local reads are given preference so that data can be supplied from the local data center upon read. Cassandra writes are fast written to a commit log and then written to the actual table location in a lazy manner. This makes the write very fast as the client don't have to wait for the data to be written to the table. Client read or write requests can be sent to any node in the cluster. Cassandra allows data ordered by the key. The data stored on the disk for a table is ordered by the primary key. This makes it faster to get the data in the key order. Normally, this will mean more time spent during insert. But due to the delayed insert in Cassandra, the client will not see inserts taking more time. Cassandra is a NoSQL database, that is, a key-value database. That means each piece of data is identified by a unique key, and you can fetch the values based on the key. Data in Cassandra is organized into key spaces. Key spaces are similar to a database in relational databases. They represent a namespace within which other objects are stored. Within key space, data is stored as tables and columns. Initially, Cassandra had the concept of column families, but they have done away with that now. Each table should have a primary key. Primary key has to be unique, and also it does not allow null values. Data is ordered by the primary key and stored. Apart from the primary key, table can have indexes that may not be unique. You can search and get data from tables using the primary key or the indexed column only. Cassandra does not allow arbitrary searches or searches where the performance is not known in advance. Cassandra is designed such that real-time update or inserts are possible. Cassandra supports a subset of the ANSI SQL called CQL. CQL stands for Cassandra Query Language. CQL has select, insert, and update commands that most software professionals are familiar with.